All right, in this lesson, we're going to take a look at mortgages and amortization. Scary words, but not too bad. In our last lesson, we took a look at annuities, which is basically the idea of paying something off over a long period of time using regular payments instead of trying to pay off one giant loan all at once. And that's really all that a mortgage is exactly that, an annuity. And amortization is a fancy word that basically just says what kind of schedule are we working on and what are the rules with the annuity. So to go through some terminology, we'll kind of do this as we go. So if you're not, completely comfortable with it, don't worry. We're going to kind of cover it as we need it. But the mortgage itself is just a secured loan for a house or some kind of similar property. Now, normally it would have to have an actual house on it, so it doesn't apply to vacant land. Again, this may change over time depending on who your lender is and what the laws are in place at the time. But the idea is that if you're buying some place to live or some place to rent or something like that, to rent to someone else, I should say, that would be a mortgage. And the reason that it's a secured loan means that, like, if I borrowed $20,000 and I told them, I'm going to use that to go to Vegas for the weekend and just have a really, really good time, if I default on my loan and don't pay them back, they have no way of getting that money back from me. It's gone. Whereas if you have a mortgage and you don't pay your loans, then they have the house and the property to come and take. And yeah, you don't want that to happen, but they're much more comfortable with knowing that they have something that they can get from you, which is why mortgages typically have much lower interest rates than other types of loans. Okay, all mortgages are going to fall into one of two categories. It's either going to be a fixed rate mortgage or a variable rate mortgage. A fixed rate mortgage, in the long run, tend to be a little bit higher, so you tend to pay a little bit more in interest if you do a fixed rate. Again, it depends over which time period you do. The last few years, fixed rate mortgages have done quite well compared to variable rate. But the idea is that you pay the exact same amount of interest and make the exact same payments over the entire term of the loan, which we'll talk about in just a moment. Um, so that means that regardless of what happens in the economy, whether interest rates go up or down, you pay the same amount, which makes them a little bit more safe for most people because you know how much your payments are going to be and how much they're going to stay. A variable rate, on the other hand, it has rates that go up and down with the economy. So if interest rates go up, then your rate goes up, meaning your payments go up. And if the rate goes down, your payments go down, um, etc. Now that's a little less stable, and I will say that for my personal mortgage, my mortgage, when the interest rates went up, my biweekly payments went from $500 to $700, which is a pretty significant increase. At the same time, I should point out that my mortgage is relatively small because I've had it for a very long time. But either way, like that was a significant increase that I had to find the extra money for. So if you're someone who like can't really afford to find a few extra $100 every 2 weeks, then you might want to go with a fixed rate, even though you end up paying more in the long run. Variable rate, you might pay more over any short-term period. So maybe over 3, 4, 5 years, you pay more for it. But over the full mortgage of your loan, you probably will save money by going variable. Again, talk to a financial advisor when it comes time to actually do this, and they'll give you some advice on which one you want to do. The amortization is just the idea that you're gradually going to pay off the loan with regular payments. It's basically what an annuity is. The amortization period is how long you're going to have your mortgage for. So for most people, that's going to be 30 years. Again, there are laws and rules that are in place that change how long this is going to be depending on a few things, and those may change after I've made this lesson. I know they've changed a couple times over the last decade or so. So you'll just talk to your bank and see what that is. But I believe that the current normal is about 30 years. And then we have the term of the loan, which people often mistake for the amortization period. It's a period of time, normally 5 years, and it's basically how long your paperwork is good for, so how much your loan agreement is good for. So what would happen is I go to the bank and I get a 30-year amortization period for a mortgage, and we agree on what the interest rate's going to be and what the payments are going to be and all that stuff. And then at the end of the term of the loan, 5 years later, um, my loan comes due, and what they do is they either set up a new term or we can change the contract. So maybe if you've got a fixed rate mortgage and at the end of the 5 years the rates have gone down, then you start a new term with the new lower interest rate. And likewise, if they've gone up, if you want to keep with a fixed rate mortgage, then you have to start it at a higher interest rate. So the interest rate you lock in is only going to be for the term of the loan, so the 4 or 5 years usually. If you want to change banks or financial institutions, you want to move your mortgage somewhere else. Let's say that you used to be banking with Royal Bank and then you've gotten married and your partner is with CIBC, so you decide to move your mortgage over to CIBC. You can do that at the end of a term of a loan. At any point during your loan, you can actually break the loan agreement and pay a penalty and then basically end your term. But there is a financial consequence of that. It's usually a few hundred to a few $1,000s that you have to pay in order to kind of start over. So for instance, if I have a variable rate mortgage, if I had decided when the rates started to skyrocket that I wanted to switch into a fixed rate mortgage and lock in so that I wouldn't get nailed for the interest rates going up, I could have done that, but I would have paid a few $1,000s penalty in order to do so, and I just decided not to bother. Anyway, the term of the loan is really all about the paperwork and the agreement, and it has very little to do with the actual mathematics that we're going to be looking at on how to solve these things. So we can ignore that for now. All right, for our first little investigation here, we're going to look into buying a home. And I just recently looked up the current interest rate, of course, when I made this video, so it may have changed since then because these things change on an almost daily basis. But RBC, the Royal Bank of Canada, had a 5-year term fixed mortgage with an APR of 6.55%. Now, APR is basically just saying the equivalent annual interest rate. It real mortgages are always by law compounded semi-annually, twice a year, despite the fact that our payments are usually going to be monthly or biweekly. So don't worry too much about this. The APRs just basically let you compare one loan to another. It basically ignores the compounding periods and just says the equivalent amount per year is 6.55%. Now, um, for us to actually do the equation properly, we have to convert this to pretend that it's compounded monthly, and that would be an equivalent 6.36% if it was compounded monthly. I don't expect you to know how that came to be, and I don't expect you to be able to calculate it. For now, just trust me that 6.36% compounded monthly is equivalent to 6.55% compounded annually. So it's a slightly lower interest rate, but it's compounded more often, and it works out to be the same as 6.55%. For this example, I just wanted to use an accurate rate. For the other examples you do, just use the APR if that's all you're given or the only number in the question, and don't worry about doing any kind of conversion. But for us, we're going to use the actual, what it should properly be is 6.36%. Okay, so we want to make monthly payments on a mortgage that's $750,000 with an amortization period of 30 years, and we want to figure out what those monthly payments are going to be. So let's set this up the same way that we would have set up any other annuity equation in our last lesson. Our payment, we don't know what that is, so we're just going to put question mark there for payment. We know that the present value of the loan, so basically the amount that we're borrowing, is $750,000. We know the interest rate in this case is 6.36%, and this is compounded monthly according to the question, so we'll divide that by 12, and 6.36% divided by 12 is 0.0053. And the number of payments is going to be 30 years at 12 payments per year, so 360 payments. Okay, so we have a present value ordinary annuity. It's an ordinary annuity because we're making payments at the end of each month from the starting date. So if we look back to the last lesson, or we just Google what the equation is, it works out to be the present value equals the payment amount times 1 minus 1 plus I to the negative n divided by I. So that's the equation we're going to use. Now we'll plug in the things we know. So 750,000 equals the unknown payment, which is the one we're trying to figure out. 1 minus 1.0053 to the exponent negative 360 divided by 0.0053. All right, so I'm going to leave this part the same. Now this time I'm going to actually work out the top of this equation, or the one piece first, just to make sure that we're getting it right, because a lot of people goof on the order of operations here. So we're going to put in 1.0053 to the exponent negative 360. The negative exponent means that we're expecting a number on this to be less than 1, so we should get a fraction or a decimal. And when I punch this into my calculator, I get 0.149126313. Okay, we're getting closer to the end. The top of that is going to end up, we do the subtraction, so we should get something around 0.85 something. And then we'll divide that by 0.0053. And the actual answer, actually, I don't know why I put a square bracket there. The actual answer to that entire bracket when we do the division is 160.54225051. Keeping more decimals than I probably need, but that's okay. And then finally, I'm going to divide both sides by that 160. And when I do that, I get out that my payment is actually going to be equal to $4,671.67, with possibly a little wee bit of rounding error, but I think I kept everything pretty accurate in there. So I think we should be okay. So what that means is that our $750,000 mortgage, we'd have to make monthly payments of $4,671 over the next 30 years. Not an insignificant amount. All right. How much would we actually pay for that mortgage over 30 years? Well, we just said that we're making payments of $4,671.67, and we're making 360 of them. And when I multiply that out of my calculator, I get, ooh, this is not pretty, $1,681,801.20, which means that our $750,000 house, we're going to end up paying almost 1.7 million for. So closing in on $1 million of interest. Now, that may seem really brutal, and it kind of is in some ways, but at the same time, that's $1 million of interest that you spent to live in a home for 30 years. That's something in itself. If you think about how much you'd spend on rent over 30 years, maybe it's not such a bad thing whatsoever. Also, at the end of this, you do have the home. And one thing to remember is that at the end of 30 years, your $750,000 home won't be worth $750,000. It's going to be worth a lot more. Home values appreciate over time. Um, the house that I currently live in was about $265,000 when I bought it, and it's probably around $700,000 now. So a significant increase in value. So maybe at the end of the 30 years, your house will be worth closer to $2 million, which makes the $1,681,000 in payments seem fairly reasonable. Again, these are all things to consider, but you'll want to talk to a financial advisor when you're ready to make these decisions. I'm just trying to kind of guide you to the ideas that you might want to think about before looking into buying a home. All right, this next part's going to be fairly quick. It's just looking at amortization tables. So whenever you do get into a loan agreement with a bank for your term, what they'll usually do is they'll give you a list of an amortization table, which is a list of future payments that you have to make. So this one just shows a few of my payments coming up. It does not by any means show all of them. I've got lots more to make over the next couple of years, but it is showing the payment dates and the interest and principal and the remaining balance. So I currently, as of now, owe about $134,529.69 left on my house. And by the end of this next year, I will owe 130,000, almost 131,000. So I will have only paid off about $4,000 of my mortgage over the next year. And that's because most of my payments, or at least a significant amount of my payments, are going to interest. So you'll notice that my next payment is $354.86 interest right here. And the amount that I go to pay off the principal, so the amount that basically goes off the amount that I borrowed or owe in the first place, is $338.29. So more than half of my payment is going towards interest. Now, I mentioned that I've had my house for quite a while. When you first start making payments, I'm going to be honest, it's almost depressing seeing how little of your payment goes towards paying off the loan and how much of it goes to paying off the actual interest. So you might say, okay, my first payment, I paid $2,000 and $1,920 went towards interest and only $80 actually went towards paying off the loan. Um, all I can say is that every time, every month, every payment that you do, it does get a little bit better and a little bit more goes to paying off the principal. In fact, something is coming up for me in the very near future, and it happens right here in May, and that will be the first time in my life where the amount of money that I'm paying towards my principal is larger than the amount of interest I'm paying. So I'm looking forward to that, seeing at least half of my payment going towards paying off the house. That's never happened in my lifetime. Okay, so let's just see if we can interpret a few things from the table. Nothing too complicated. The first one is how often do I make payments? Or well, it's me, but basically, if I just look at these dates here, between January 12th and January 26th, that's 2 weeks. January 26th to February 9th, that's also 2 weeks. So these are biweekly payments every 2 weeks. Okay, that was pretty easy. And then how much is each payment? Well, it doesn't actually say this on here. Some amortization tables will say it, some don't. It's really easy to figure out though if it doesn't say it. And your payment is going to be equal to your interest plus your principal. And I can use any interest principal payment I want. I'm going to use my very first one, the $354.86 plus the $338.29. And that means that my actual payments are going to work out to be $693.15, which is just shy of 700, which I mentioned earlier. Okay, so this amortization table is what's currently in effect, and because I have a variable mortgage, it's subject to change. If the interest rates go up in 2 months, then what they'll do is they'll give me a new amortization table saying how much I'm going to owe each payment every 2 weeks, and it's going to tell me how much of that goes towards interest and how much goes towards principal. Now, by the way, the fact that I chose the first line for this calculation is irrelevant. If you chose any line on this, you should be able to add up the principal and the interest and get the same number. Just looking at the bottom, I think you can see that 680, 92, $93 and yeah, 15 cents, something like that. So yeah, I think that's probably about it for this lesson. Give the questions a try, and I wish you the best of luck.